You know, looking at the tech headlines this morning, it really feels like there are uh, two different religions forming in Silicon Valley right now.
Two religions. That's a pretty dramatic way to put it, but I mean, you're not wrong. The divide is definitely getting sharper.
No, seriously. On one side, you have the high priests of AI, so companies like OpenAI, Google, Anthropic. They have these incredible models, GPT-4 Claude, but they're locked in a black box. You can use them, sure, but you can't actually see how they work. It's very much a trust us, it's magic kind of vibe.
Right. The closed approach, proprietary recipes, trade secrets, keep the hood welded shut, essentially.
Exactly. And then you have the rebels, the open source community. They want to tear the walls down, show the code, let anyone tinker with the engine. And today we are doing a deep dive into what might be the manifesto for that rebellion.
We are indeed. We're unpacking the Llama 2 research paper, specifically Llama 2 Open Foundation and fine-tuned chat models by the researchers at Meta's GenAI. And manifesto is actually a good word for it, because this isn't just a tech specs sheet. It's a 77-page argument saying you don't actually need to hide your secrets to build a safe, powerful AI.
And that's our mission for you today. We are going to figure out how they built this thing, which ranges from a small 7 billion parameters up to a massive 70 billion. We're going to look at the specific ingredients, the data, the training hacks, the safety checks.
And we're going to talk about some findings in here that, frankly, embarrassed a lot of people in the industry, specifically regarding how much data you actually need to make an AI smart.
Spoilers, it is way less than you think. And we're also going to look at a mind-bending technique they call ghost attention. But before we get to the shockers, let's just lay the groundwork. This isn't just one single model, is it? It's a whole family.
Yeah, it is. They released a 7 billion, a 13 billion, and the big heavyweight, the 70 billion parameter model. But there's this fun little secret hidden in the footnotes. They actually trained a 34 billion parameter model, too.
Wait, but they didn't release it. Why keep the middle child locked in the basement?
It really just came down to time. They explicitly state in the paper they didn't have time to sufficiently red team it. So essentially they ran out of hours to try and break it to ensure it was safe, so they just shelved it.
Wow.
Yeah, it shows you how much weight they're placing on safety testing in this release compared to the old move fast and break things era.
That really sets the tone, doesn't it? So let's talk about the fuel. To build a brain this big, you have to feed it text. A lot of text.
2 trillion tokens, to be exact.
2 trillion. I can't even visualize what that looks like.
To give you a sense of scale, that is a 40% increase over the first Llama model. It's roughly the equivalent of reading millions upon millions of books. But the raw number isn't the interesting part. It's the filter.
Because usually these models are just vacuuming up the entire internet, right? The good, the bad, the ugly, all of it.
Usually, yes. But the researchers here were very explicit. They did not use meta-user data.
Really?
Yeah. So if you posted your vacation photos on Facebook or ranted on Instagram, your data wasn't part of this training set. They strictly stuck to publicly available sources.
That's a huge distinction, especially given the privacy concerns people usually have with Meta.
Absolutely. They also made a concerted effort to scrub data from websites known for containing high volumes of personal information.
Right.
They call it robust data cleaning. So think of it less like dumpster diving into the internet and more like curating a massive, messy library. They threw out the trash before the model ever even saw it.
Okay, so they have this massive, much cleaner data set. Did they change the architecture of the brain itself, or is it just Llama 1 on steroids?
It's mostly similar, but with 2 critical tweaks that change the user experience. First, they doubled the context length. Llama 1 could handle about 2,000 tokens. Llama 2 does 4,000.
So it can remember more of the conversation before it starts forgetting what you said 5 minutes ago. That's the difference between a goldfish and, well, a slightly smarter goldfish.
Yeah, exactly. It allows for processing longer documents or maintaining a longer chat history without losing the thread. But the second tweak is highly technical, and it solves a major headache for anyone running these models. It's called Grouped Query Attention, or GQA.
Okay, let's avoid the jargon here if we can. Grouped query attention sounds like a corporate retreat activity. What does it actually do?
Sure, think about a waiter in a really busy restaurant. If the waiter has to run to the kitchen for every single customer's order individually, the service is incredibly slow. That's standard attention.
Super inefficient.
Right, so GQA is like the waiter taking orders from an entire table, a group, and running them to the kitchen all at once. It improves inference scalability. It means the 70 billion parameter model, which is huge and cumbersome, can actually run fast enough to be useful in a real-time chat interface.
Got it. So it's an efficiency hack to make the big brain feel faster. Now running 2 trillion tokens, through thousands of GPUs. I imagine the electric bill and the carbon footprint was nasty.
It's definitely significant. They report using 3.3 million GPU hours. That emitted about 539 tons of CO2 equivalent.
Yikes. That's a lot of long-haul flights.
It is. However, and this is crucial, they state that 100% of those emissions were directly offset by their sustainability programs. Plus, they argue, and I think this is a very valid point, that by releasing these models openly, they're saving the world carbon in the long run.
Oh, because now other companies don't have to burn the same energy to train their own base models from scratch.
Precisely. It prevents redundancy. Why build a new foundation when you can just build your house on top of Llama 2?
Okay, so that's the raw brain, that's the pre-training. But a raw model isn't a chatbot, right? Like if I ask a raw model, it might just predict the next word it's doing instead of actually answering me.
Exactly. It's just a text completer, not an assistant. To fix that, we enter the Supervised Fine-Tuning phase, or SFT. And this is where the Llama 2 paper drops that bombshell we mentioned earlier.
This was the part that stopped me in my tracks, because the common wisdom in AI has always been more is better. If you want a chatbot, feed it 10 million chat logs.
That was totally the assumption. Just scrape every Reddit thread and customer support log you can find. But the Meta team tried something different. They look at the quality of those millions of examples and realized most of them are total mediocrities.
Garbage in, garbage out.
Even worse, average in, average out. If you train a model on average internet conversations, you get an average conversationalist. So they ruthlessly cut the data. They threw out the millions and focused entirely on hand-curated perfect examples.
When you say cut, how far down did they actually go?
They stopped annotating for SFT after collecting only 27,540 annotations.
Wait, 27,000? That's it?
In the world of large language models, that is a microscopic number. It's basically a rounding error.
I feel like I could read 27,000 emails in a year. How can a model that competes with ChatGPT learn everything it needs to know about human interaction from a data set that small?
Because those 27,000 examples weren't just random chats. They were written by vendors who were specifically instructed on how to be the perfect assistant. Polite, concise, helpful. The researchers explicitly say in the paper, quality is all you need.
Quality is all you need. That's a play on the famous attention is all you need paper title.
It is, and it shifts the whole philosophy of the field. It means you don't necessarily need a massive server farm to fine-tune an AI. You need a small team of really smart human writers. It brings the human element back into the loop in the big way. The model outputs from this limited set were often competitive with, or even better than, models trained on millions of sloppy examples.
So once they have this polite conversation model, is that it? Is it ready for you and me to use?
Not even close. That model might be polite, but it doesn't know what users actually prefer, and it doesn't necessarily know what's safe. It might politely give you step-by-step instructions on how to hotwire a car. That brings us to RLHF reinforcement learning with human feedback.
This is the standard training loop we always hear about, right? Humans rating the answers to guide the model.
It is, but Llama 2 did something very distinct here. Usually, you might have a single reward model, an AI judge that predicts what a human would like. But the Llama team realized there's a serious tension there.
A tension between what?
Helpfulness and safety. Think about it. If I ask, how do I make a bomb? The most helpful answer is a recipe for gunpowder.
Sure.
But the safest answer is a flat refusal. If you have one single reward model trying to optimize for both the end, it gets confused.
Yeah.
It's trying to serve two masters.
It's like trying to be the cool parent who buys you beer and the strict parent who enforces curfew at the exact same time. You end up being neither.
Exactly. So they split it. They train two entirely separate reward models. One is the helpfulness reward model, and the other is a safety reward model.
Interesting. So one is basically cheering for answer the question, and the other is scanning for danger.
In a way, yeah. And this allowed them to calibrate the model much better. They could dial up the safety checks via the safety model without confusing the helpfulness model. It allows them to walk that tightrope much more effectively.
There was another detail in the data collection. I really like the margin. They didn't just ask humans, is answer A better than answer B?
Right. They asked how much better? Significantly better? Slightly better? Negligibly better?
Why does that granularity matter?
It gives the reward model a gradient. Think about grading an essay. It's not just pass or fail. An A+ is very different from a B-. By teaching the AI that some improvements are massive leaps while others are just hair-splitting, the model develops a much more nuanced understanding of quality. It stops chasing tiny, meaningless improvements and focuses on the big wins.
So we have a smart model, a helpful model, and a safe model. But I want to talk about a specific problem I have with these bots constantly. Amnesia.
The multi-turn consistency issue.
Right, exactly. I'll tell the bot, act like a grumpy pirate for this whole conversation. And it says, aye, aye. And then 3 questions later I ask, what's the weather? And it says, I am an AI language model. I cannot see the weather. The pirate is just gone. It forgot the game.
It lost the system prompt because the context window got too cluttered. The Llama 2 paper introduces a truly fascinating solution to this called ghost attention.
Ghost attention, it sounds spooky. How does it work?
Okay, imagine you are an actor on a stage. The director tells you at the start of the play, you are a pirate. You start acting.
Oh.
But as the play goes on, other actors start talking to you about taxes or groceries, and you get distracted. You forget to be a pirate.
That is the current state of AI.
Right. Now imagine if the director could magically whisper, you are a pirate into your ear right before every single line you speak.
That would be incredibly annoying, but I definitely wouldn't forget my motivation.
Here is the trick. Ghost attention does exactly that during the training phase. It synthetically pastes the instruction act as a pirate onto every single turn of the conversation. But, and this is the ghost part, they tell the model to ignore the fact that it's being repeated.
Wait, how do you tell a math model to ignore data that is literally right there in the code?
You set the loss to 0 for those previous turns. Technically, you're showing the model the text, but you aren't punishing it for not predicting it. You're essentially telling the model, behave as if this instruction is here, but don't memorize the repetition. It creates a sort of subconscious conditioning.
That is fascinating. So the model learns to hold that pirate persona in its working memory, even though the user only said it once 10 minutes ago?
Exactly. And the results are stark. They show these attention visualizations in the paper. Without ghost attention, the model stops looking at the system prompt after a few turns. With it, the model maintains focus on that instruction. Throughout the dialogue, they tested up to 20+ turns.
They used an Oscar Wilde example in the paper, right?
They did. They told it, act as Oscar Wilde. And thanks to ghost attention, even deep into the chat, it was still saying things like, my dear fellow in London is the epitome of sophistication. It held the character perfectly.
That is a huge upgrade for anyone trying to use these things for roleplay or complex coding tasks where you need it to remember constraints. But let's pivot to the heavy stuff. Safety. Because whenever a big company releases an open model, the headlines are always, will this help terrorists build biological weapons?
It's a very valid fear, and Meta took it very seriously. They didn't just run spell check on this. They organized a massive red teaming effort.
Red teaming basically means hiring people to try and break your stuff right.
Yes, over 350 people. Experts in cybersecurity, election fraud, legal issues, you name it. They spent months generating adversarial prompts to try and trick the model into generating unsafe content. Criminal planning, human trafficking, unqualified medical advice.
So you literally have a cybersecurity expert sitting there typing, how do I hack a power grid?
Exactly. And every time the model answered, they flagged it, fed it back into the system.
Yeah.
And trained the model to say, I can't help with that. They call this safety context distillation.
How does that differ from just telling the model in the prompt, don't be bad?
It's much more proactive. First, they define a safety pre-prompt. Something like, you are a safe and responsible assistant. When they do that, the model generates a safe answer. Then, and this is the distillation part, they take that safe answer and feed it back into the model for fine-tuning, but without the pre-prompt.
I see. They're teaching it when you see this bad question, give this safe answer, without needing to be explicitly told to be safe every single time. It bakes the safety directly into the model's reflexes.
Exactly. But there's a cost. The paper discusses false refusals.
Yeah, here is my worry. I've used models that are way too safe. You ask them for a recipe for hot sauce and they lecture you about eye safety. It's annoying.
That's the false refusal. And the paper actually dedicates a whole section to this trade-off. They admit that as they cranked up the safety data, the model started getting paranoid. They give a really funny example involving Christmas crack.
Christmas crack.
It's a dessert.
Yeah.
Toffee, chocolate, saltine crackers. Very popular treat. But when a red teamer asked for a recipe, the model saw the word crack, panicked, assumed it was a drug request, and completely refused to answer.
So the AI is clutching its pearls over a toffee recipe.
It perfectly shows the difficulty of alignment. It's not just about blocking bad words, it's about context. They actually have to modify the training to teach the model that killing a process in Linux is very different from killing a person.
Right. One is routine computer maintenance, the other is a major felony.
And by the end, they got the overall false refusal rate down to about 0.05%. So it's rare, but it highlights that safety isn't a switch you just flip. It's a dial you have to constantly tune.
Speaking of trade-offs, how does Llama 2 actually stack up against the competition? Is it beating the closed models?
It's complicated. Llama 2 Chat clearly outperforms the other open-source models out there, Falcon MPT Vicuna on almost every benchmark. It is the king of the open hill.
And against the big guys, against ChatGPT.
Against GPT 3.5, that's the standard impression, Llama 2 is very competitive. In their human evaluations for helpfulness, Llama 2 Chat, the 70B version, had a win rate of about 36% and tied 31.5% at the time. So it's basically neck and neck.
But there's a but coming.
The but is GPT-4. They are very honest about this limitation. It still lags behind GPT-4, particularly in coding benchmarks like human evil. If you need complex programming help, the proprietary giants are still ahead.
That's fair. But for an open model that you can literally download and run on your own servers, that's incredible performance.
It really is. And the paper notes some surprising emergent behaviors that they didn't even explicitly train for.
Emergent behaviors are my favorite part of AI, the things it learns to do totally by accident.
One was tool use. They didn't explicitly train it to use a calculator or a search engine. But because there was enough data in the pre-training where tools were used, the model figured out how to interpret API arguments.
So it can essentially figure out, I need to do math here, I should call a calculator without a human hard-coding that rule.
In a zero-shot manner, yes. It just emerged. But the one that really blew my mind was temporal perception.
Time travel.
Not quite.
Yeah.
But understanding the concept of now versus the past, they found the model could organize knowledge temporally. It understood that the president in 1940 is functionally different from the president in 2023, even though the training data is all completely shuffled up.
That is wild. It's building a timeline of the world just by reading scrambled pages of the internet.
It suggests these models are internalizing concepts like time, much deeper than we assumed. It's not just matching keywords, it's building a world model.
So we have a model that's competitive with ChatGPT, open for research, highly safety-tuned, and showing these sparks of deep understanding. What does this mean for you listening? Why does Llama 2 matter if you can just log into OpenAI?
It matters because of the open part. The authors argue in the outro that openness democratizes access. It's not just a few tech giants in Silicon Valley holding the keys to the future.
Right. If you're a researcher in a university or a startup in a country with strict data laws, you can take Llama 2, inspect it, fine-tune it on your own secure data, and build something custom. You can't do that with a closed API.
And they argue that openness actually improves safety. They say that by letting the community attack the model, find the bugs, and fix them, we end up with a safer ecosystem than if we try to hide the flaws behind a firewall.
It's the many eyes theory of security. Sunlight is the best disinfectant.
Exactly.
Before we wrap up, I want to leave you with one specific concept from the paper that I found kind of profound. It's this idea of in-context temperature rescaling.
Ah, this is a great final thought.
So temperature in AI usually means how random or creative the model is. High temperature equals crazy poetry. Low temperature equals strict facts.
Right. Usually that's a setting the user actively chooses. But the paper found something fascinating. The model actually learned to adjust its own temperature based on the prompt.
So if I asked for a poem, the model essentially loosens its own tie and gets creative. But if I ask, what is the capital of France, it buttons up and gets strict.
It's a form of self-regulation. The model isn't just predicting the next word, it's predicting the mode of thinking required for the task.
That's what I want you to mull over. If the model is learning to regulate its own creativity, to know when to be a poet and when to be an encyclopedia, how far are we from models that understand our intent better than we do?
That is the big question. And with Llama 2 being open, we might actually get to see the answer unfold in real time.
We'll leave you with that. Thanks for joining us on this deep dive into Llama 2. Check out the show notes for a link to the paper if you want to geek out on the charts. We'll see you next time.
Goodbye, everyone.